The next type of plot I'm going to show you, it's basically a scatter plot, but it's set up, I'm just setting up a scatter plot for my own purposes so that I can plot individual points. I'll show you what I mean. First, the plot function is a very general plot function, but it is typically used for scatter plots. And I'm just going to plot wags on the y-axis. I'm using the formula specification, so that means that this dependent or response variable will be plotted on the y-axis, and this variable will be plotted on the x-axis. And that variable is type, which is a factor, but I'm converting it to a number so that it can be plotted on the x-axis as a number. And I'm just specifying the data argument, which plot can take a data argument as well. Did I do that before? Yeah, I did that with box plot as well. With bar plot, I didn't because bar plot expected a vector of the actual values to plot. It's not going to calculate the means for me. So here, this just plots all of the values of wags at 1, 2, 3, and 4 along the x-axis for each of the values of type. So far, this x-axis is not very useful. It just has printed as .numeric of type as its label because that's what it is, and it's plotted as though these are real numbers with like 1.5 showing up as a label, for example, when in fact that doesn't make sense conceptually for what I'm doing. But I'm doing it this way initially so that I can show you how I'm setting up the plot that I eventually want to have step by step. That's what this comment here says. I'm going to repeat the same plot multiple times, and each time I'm going to add features. So the first feature I'm going to add is I'm going to show that same plot without the x-axis. So this portion of the function call is exactly the same, plotting this formula wags tilde as numeric of type with data equals dat, the data frame that I have available. And one more argument, x-axt equals none. This is x-axis type, and none is the key word indicating that I would like it not to plot the x-axis in this function call. If you ever forget these kinds of arguments, which I do all the time, I suggest looking at the documentation for par, which is the function that adjusts graphics parameters. If I look at that documentation, then I have a list of all sorts of useful arguments for graphics parameters, one of which is xaxt right here. So I can see that xaxt is a character which specifies the x-axis type, and it has various options. N suppresses plotting of the axis. You are allowed to write out none instead of just having it be n, which is what I've done here. So when I call this version of the plot function, it's going to overwrite the existing plot with another copy of it that's exactly the same except without the x-axis plotted. So this is one step in the right direction because those numbers didn't mean anything to me. The next thing I'm going to do is take that exact same function call and add even more arguments, the MGP and TCL arguments, because these make the spacing prettier in my opinion. You can look up what those mean here in the par documentation. MGP, for example, gives information about how the margins are going to be displayed, and the TCL is just tick length. That's how long the ticks are. You can see some ticks on the y-axis pointing at each of the numbers labeling that axis. So when I run it with this version of MGP and a tick length equal to -0.3, negative because I want the ticks to point out of the graph instead of into the graph, but you could, just to illustrate, you could have them point into the graph instead. But most of the time we want our ticks to be negative because that will mean they'll point out of the graph. So I made the ticks a little shorter and moved the labels a little closer to the axis, and I think that's prettier. So these extra arguments here didn't do very much except for make the plot a little prettier in my opinion. So this is what it looked like before with all this extra space, and this is what it looked like after. The next thing I'm going to add is this argument. I've moved the MGP and TCL arguments onto a new line, so I can add my new argument right here. And this just changes the x limit, the extent of the x-axis, to range from 0.3 to 4.7. instead of whatever its default was. Remember, these points are plotted at 1, 2, 3, and 4 because that's what happened when I converted type to a numeric variable. So I just want a little more space to the left and right of those points. So when I run the plot with that extra argument added in, I get that little bit of extra space. Again, this is just me making it look prettier in my opinion. The next thing I'm going to do is keep all those same arguments that I had before. So now it's starting to look a little messy, but just keep in mind that these are all the same things you've seen before, except with some new stuff. So here, all of this is there from before. And what I'm adding is ylab equals wags. The old label was wags with a lowercase w by default because that's the name of the variable. So I'm specifying that I want the y label to be this, any arbitrary string I want, but here I just want it to be wags with a capital W. And xlab should be type of dog instead of as numeric of type. And pch will be 16. That's just a particular plotting character that I sometimes like to use. I like 16 and 20. There's lots of ones to choose from. You can plot with triangles or squares. You can plot with letters if you want, but this will be filled in circles. So adding ylab changed this label to, oh, you can't see where I'm pointing with the mouse. It changed the y-axis label to wags with a capital W. Adding xlab changed the label on the x-axis to type of dog, and changing pch to 16 instead of the default made these filled in circles instead of empty circles. The next step that I'm going to show you is, again, all of this is exactly the same up to here. All of those arguments are the same. I'm only changing one argument here. I'm adding the argument call for color. And before, I've done things like blue or red here to show you how you can change the color. But you can also use a string representing the color that provides RGB values as a hex code. So if you've done any web coding, you've encountered these things before. The first 6 numbers here are the RGB value hex code of the color I want to plot in. 0 for red, 0 for blue, and 0 for green. That's black. That's nothing all that interesting. The number sign, the pound sign or hashtag, if you're hyper modern, is what's necessary to tell R that you're using an RGB hex code here. So this portion is the standard hex code for black. But you're allowed to add 2 more numbers after the hex code when you do it this way. That represents how opaque you want those points to be. So 20 will plot them kind of semi-transparent. I'll show you what that looks like. There it is. So now the points are all plotted in a light shade of gray, but it's not really a light shade of gray. It's solid black, but it's just transparent. So that when 2 points are plotted at the same location, it gets darker. The point here is so that the result will be that I have darker points where there are more points plotted, because remember, there are some dogs who had the same number of wags. And so, for example, in the points plotted on the far left, you can see that 19 appears to be the darkest one because there are several points overlapping there. This is one way to show in a scatter plot, and this is still a scatter plot. I'm just making it look pretty different from a typical scatter plot. To show in a scatter plot how many points are overlapping at the same location. The next thing that I'm going to do, I'm adding 2 more things to this version of the function call. The first, I'm calling exactly the same function with one additional argument, which I've positioned here. Ylim is the concatenation of 0 and 45. So the default y-axis ranged from like 14 to 44 or whatever. I would like it to range from 0 to 45, maybe because 0 is a significant value here. If there was a dog that had no wags, poor dog. So I'm specifying that it should range from 0 to 45. You've seen that argument already. Otherwise, this function call should be familiar to you. The other new thing I'm doing is I'm adding this before it, this call to the par function. That sets some graphic parameters before you actually call a plot. It sets up the plotting window. The only argument I'm supplying there is MAR for margins. I'm just going to specify the margins of this plotting window should be 4 on the bottom, This is in the order bottom, left, top, right. So 4 on the bottom, 3 on the left, 1 on top, and 1 on the right. Those are the number of lines of text it leaves space for in those margins. And the reason I'm doing this is that these default margins are too big, in my opinion, especially on the top, because I don't usually like to have a title. Let me just be clear. You should have titles for your plots. I don't usually like to let R manage the title for the plot. I'm going to do that in my actual document. Like if I'm sharing this with people, I'm going to mess with the titles in the document that I'm putting the plot into most of the time. But you can, of course, have R generate a main title as well. So the par function here just sets up an empty plotting window, which you can't see. It's just ready for this plot command. And there's the plot command. All it did was stretch out the y-axis and shrink these margins on the top and the right and a little bit on the left as well. So I'm pretty happy with this plot right now. I just want to add some things to it. So I'm not going to rerun the plot anymore. The first thing I'm going to do is add some text along the x-axis to label these 4 clusters of points properly instead of as 1, 2, 3, and 4. And I'm going to use the mtext function for that. That's margin text. And that lets me put some arbitrary text in the margins of a plot. The text is going to be the levels of $type. Levels, remember, prints the string labels for the levels of a factor. So there are 4 values there representing each of these 4 types of dogs. Side equals 1 means I want to print these at the bottom. Each of the sides has a number. The bottom is 1, the left is 2, and so forth. And at is the x-coordinate I want to plot those strings at. So I want to plot them at the positions 1, 2, 3, and 4 because there are 4 values there. Mtext printed Basenji, Beagle, Dachshund, and Greyhound at the positions 1, 2, 3, and 4 along the axis. And so now it's clear what these clusters of points represent. And I'm going to add one more thing to this plot. I'm going to add means and standard errors. And so I'm using points, just like I did when I had the box plot, to plot some points at x coordinates represented by 1, 2, 3, and 4 plus 0.1. You can do this, by the way. Maybe you haven't seen this before, but 1:4 just generates a vector of integers 1, 2, 3, and 4. And you can add a constant to an entire vector. So the result of the selected code right now, 1:4 plus 0.1, will be the vector of values 1.1, 2.1, 3.1, and 4.1. So I'm going to plot some points at those positions, which will be just next to the clusters of gray points that I already have plotted. The points I'm going to plot are m, that's the vector of 4 means that we stored earlier, representing the average wags for each of these dog types. I'm going to use plotting character 16, and I'm going to use the color blue. So there's those 4 points that I added. They're just next to the gray points because they're plotted not at 1, 2, 3, and 4, but at 1.1, 2.1, and so forth. And then I'm going to use another for loop to plot 4 lines representing the standard error bars. This is exactly the same as how I've done it before, so I'm not going to walk through each piece of it except to note that now the x-coordinate is in turns 1.1, 2.1, 3.1, and 4.1. So I did C I, comma, I plus 0.1 for each of these x-coordinates. Okay, so now what I have here is a plot of the same information that was in the box plot, but represented in a different way. I mean, it's not exactly the same information here. You don't have the median plotted exactly, for example, but it gives you information about the distribution of wags for each of these types of dog, and it gives you the mean plotted in blue with standard error bars. And so this is another way of representing the same information, and one that I sometimes find useful. Questions about that? Yeah.
For the types of dogs, is there an easy way to capitalize those other than like within the plotting stuff, or would you go back to the variable and
No, yeah, you don't have to go back to the variable. Mtext can produce any arbitrary text in the margin. So I used levels of $type here, but I could, for example, make a version of this mtext function call that just calls them ASDF
oh
QWR and those things. And if I ran that right now, it would put that text over the top of the labels that were already there, so that's not that interesting. But if I called the plot again and then ran that version of mtext instead, then I get those arbitrary labels. So of course those arbitrary labels could be capitalized versions of the factor level names or anything that I wanted them to be. They could even be something like, hi, Allie. Um, that /n, \n, it indicates a line break. It
Oh,
printed the high up within the graph, so I would want to print these lower so that they would both fall outside of the graph, but I could do that.
that's so cool. Okay, awesome. Thank you.
No problem. So the selected code together is what is necessary to produce the plot that I had before, right? I initialize the plotting space with the par line. The plot function generates all the gray dots. Mtext labels the x-axis, and points and lines down here create the means and standard error bars.